Hello all and welcome to today's webinar on HYDAC's Australia's Industrial IoT Applications. My name is Dimitri Levitt and let's get on with our Industrial IoT Applications. My contact details are down the bottom if you want to get in touch. So today we'll cover HYDAC Australia's automation team. So I'm not sure if some people will know, but we have quite a large automation and programming team within HYDAC Australia, here based in Melbourne. And just wanted to go over our team and our capabilities and that sort of stuff. And we'll go into industrial IoT and the applications and cloud solutions that we have within HYDAC. So the automation and control engineering team within HYDAC, or the ACE team, is our automation, electronics and programming division within HYDAC Australia here, and we're based out of Melbourne here. So we do electro-hydraulic projects, software development and electrical panel manufacture, wiring. So you can see some pictures of some of the applications, and down the bottom right is our senior electrician, Martin Dobbin, who's performing some wiring. And we're quite experienced in hazardous area as well. We have ATEX and IC EX-RAID approved. So yeah, we can tackle projects in those areas as well. So we want to go over some of the growth of our automation and control engineering team. As you can see, started in 2014, and we've seen quite considerable growth. I don't know what happened to the last three numbers. It should be 2018, 2019, and 2020. So I do apologize for that, but we've seen quite considerable growth over the years. So the team is made up of mechatronics and programming engineers. We have embedded software developers, A-grade electricians, apprentices as well, and some of our capabilities are electrical and mechatronic engineering, design, control panel manufacture, control panel design, algorithm development, and in particular, we focus on fault-tolerant software. So we try to, when we write software, we want to make sure that it works in every condition and is fault-tolerant and is 100% reliable. We undergo testing, we undergo code reviews, and we also go over workshops where we bounce ideas around in regards to software. So we're experienced in embedded software development, firmware development, also programming a number of programming languages, C, C++, Codesys, MATLAB, Java, some of the environments like MATLAB and Codesys, and also Linux OS operating system experience, servers and networking and remote access, and vision systems. So we do some projects with vision systems, LiDARs and things like that. So I wanted to go over like the HYDAC group offering here within Australia. So let's start, for example, you have your application down the bottom there. This is your application. In that application, you have sensors, actuators, powers, components, and we can offer sensors, pumps, motors, valves, cylinders, etc. Then on top of that, you probably have a electronic or electrical piece of hardware like a PLC or an ECU if we're talking about mobile applications. We have I/O modules, we have edge computing like high-performance computers, switches, gateways for data transmission, Ethernet switches and things like that. So we can offer that as well. Then we have your middleware tools like your OS or your runtime systems and things like that. So we provide that as well. We can also perform advanced analytics and AI for perception algorithms and assistant and functions. We then focus on your specific application and do the software development, conceptualization, programming, things like that. And we also have user interfaces, HMIs, so physical HMIs, displays, and web visualizations. For example, some of our edge computers, you may not want to have a physical HMI, and we can provide a web visualization for that. We have connectivity, IoT gateways, and also going up to the cloud platform and cloud service. So from our offering, we can offer the HYDAC. From our point of view, we can provide you pretty much with a whole complete solution, electronic, hydraulic, or both, and software as well. So let's talk about industrial IoT. I hope everyone's already heard of the term IoT, or Internet of Things. And all this is effectively a fleet of devices. Let's say if you have a hydraulic power unit, which is what a HPU is, you have a machine or a truck, you have a fixed plant or an asset, or a smart meter is a very good application. So, some of our new smart meters that may be on your house are all connected to cloud generally. And then you have these fleet of devices, and either through a GSM network, mobile network, or Wi-Fi, you go to cloud. So cloud, when I'm referring to cloud here, is a network of computers that physically are located somewhere in a whole bunch of servers, data centers, compute power, and things like that that collect all this data and present it back to you in either sometimes in a form of an app or in a form of a dashboard, or even generate an email or an SMS and things like that. So the data is stored there, and then we can view the data of an asset or a device or anything like that. So we connect a device to the internet and display the information to you in a particular way that you want, either on a smartphone, laptop, tablet, via email, reports, or anything like that. So that effectively is an industrial IoT application. And then obviously we have layers of security, we have encryption and things like that. So when we do provide industrial IoT applications, we do have security standards, encryptions, and things like that, and we can provide you with all that information. So let's break down an industrial IoT application. Let's say. So we have a sensor, and in this particular case, I have an IO-Link sensor. If you don't know what IO-Link is, I've did a webinar on smart sensors, so please feel free to find that on our HYDAC YouTube channel. The webinar is called Smart Sensors, and I go into depth about IO-Link and show you some cool functionality of smart sensors. So yeah, feel free to check that out. So we have a sensor, and this particular sensor is IO-Link. We're going IO-Link to an IO-Link hub or a master or an IO hub, for example. And this could be just a IO module that's collecting sensors. And then we're going via field bus to an edge PC. And in this particular case, we don't need to have an HPC. This could be your PLC already that's existing on your plant or your machine. And then we can provide a local visualization. So by I mean local, we have no internet connectivity. So this HPC does not connect to the internet. It serves a website that you can log in and you can see real-time data of your asset or of your sensors. And if you want to analyze, create some dashboards and things like that. And we can also connect this HPC to your SCADA system if you like, and things like that via Modbus, OPC UA, Profinet, and other particular interfaces. So that's what I mean local. And then when we go to cloud, we transfer the pre-processed data to cloud. And there we provide you with a way to view that data, a secure way to view your data in dashboards, or we can provide you with proactive emailing and alarming. So if we want to look down, that's effectively what an IoT application can look like. Sometimes you can have sensors that just go straight to cloud or things like that. So, effectively, this is what it would look like. So one of the applications we've done recently, we've done a number of applications actually like this, and it's effectively a managed IoT solution that we can deploy assets quite quickly. We can deploy these systems quickly, and we have the infrastructure and the ability to handle the traffic or the internet traffic and the ingesting of multiple assets. So in this application, we're monitoring assets on customers' site and sending data to cloud. So monitoring things like water usage, energy usage, and things like that for manufacturing facilities. So for example, we have a sensor set, and in this particular case, we use IO-Link sensors. We went to an IO-Link master. We were communicating via Modbus TCP to our Data Plus edge computer, which I'll go into a bit more. This is quite a flexible and powerful computer which can be used in IoT applications. With the edge computer, we're also serving web pages locally. So we could view the data locally at a high resolution. So we had a filter set up on this, I think it was an epsilon filter, where we were monitoring on change of a 0.0001 decimal of whatever value we were using, but we can change that. We can have log on changes required. So we had multiple interfaces. We had a local 5-inch HMI as well on the system, plus using an industrial IoT router, we were able to create a Wi-Fi hotspot to allow mobile devices to connect and view data locally. Plus, we were also going to the cloud where we were presenting the customer with a view to see all of their assets in one location. So that's one of the big benefits of having a cloud platform, secured cloud platform. And with designing the system like this, we were also aware that we needed to deploy and handle the large deployment factor and the large compute power that would be required, or the traffic, being able to have the load balancing and things like that available. So if we had to deploy a number of devices, and as we grew, we could scale. So the Data Plus Edge box, the Data Plus Edge PC, is effectively a industrial PC which has processing power on board, where it collects data, has a database, Postgres, and a timescale database on board. And with a local visualization, we can view the data locally and customize it, create dashboards quite easily and intuitively and things like that. So it's quite a powerful and robust and flexible edge computer. So we've done a number of projects with this. It runs on a Linux OS, and we have our own software running on top, which presents the dashboards and the customization and the configuration. So an example of like how this would look like in an industrial setting. So you have one particular site. We can connect a number of assets to the Data Plus, and then later on you want to go to the cloud. So if you wanted to start off first, you can have just local access, view the data locally, maybe go to your SCADA, and then later on, if you want to add a cloud connectivity, that's fine. We can do that as well. And then if you add another, might have another factory or another device that's physically located somewhere else, or maybe same plant or something like that, we can send that data to cloud. And then as you expand, we can expand. And with the cloud solutions, we can connect to our cloud or a specific cloud of your choice. So it's quite a flexible solution. Now, I also wanted to touch on our solutions on our off-highway or mobile cloud solutions, which is, so the applications we looked at before were industrial-based, so fixed plant, let's say. And now let's have a look at our off-highway or mobile plant applications. So our off-highway mobile cloud solution, what we call is our TTConnect cloud service. And this is with one of our companies, TT Control, and I'll go over into TT Control. If you want to look up this company, it's quite a cool company that is 50-50 owned by HYDAC and TT Tech, both quite interesting companies, and a lot of innovations are coming out from there. So as you can see here, we have the TTConnect Wave. That is our ruggedized IoT gateway, and this is the device that connects to the cloud or to the internet and also connects to your machine. And how does this work? So the cloud service, what we provide to you as a solution, provides you with the hardware, the SIM card, and the cloud solution. So everything is managed by us. So all that's required is setting up the CAN configuration, CAN messages that you're sending through that you're reading from the Data Plus. The SIM card with a private APN, we have a roaming SIM card, or you can use your own SIM card if you choose, and a cloud platform where you actually go and view the data and view your assets and machines. So how does it work? We have the IoT gateway, the TTConnect Wave. You install this onto a machine, and this can be already a machine that's already running. Let's say, if you know the CAN message structure, you set up the Connect Wave, you connect the TTConnect Wave to the CAN network on the machine. And with that, you set up the messages you want to listen to on the cloud platform. So the gateway itself is deployed and doesn't need to be programmed. It is only ever configured by, the only thing you do is you insert a SIM card and configure the APN if you're using your own SIM card. And then the rest is done on the cloud. You set up the database structure, you set up the CAN messaging, which is what we call the CAN database, so the CAN message database. And then as soon as that's set up, all you do is you cycle power to the wave, and then it starts listening to the messages and starts transmitting them to the cloud. And we store the data on the cloud, and we present that information to you via the web portal, which is our TTConnect cloud solution. And then you can view that information either via on your laptop or on any device. And via that, we can also send data from the cloud to the device, for example, settings or things like that. And we can also actually manage software of the controllers, the controllers that are connected to the TTConnect Wave via the cloud. So if you need to push a software update to your controller, you can do this via the cloud. So you don't need to go to site to do this anymore. So you can do this via the cloud, which is quite a cool feature. And what does this look like? Another thing, so if you have multiple devices, we can connect this up so we can scale up and down as required. And we have all the service and the server infrastructure, everything set up to be able to handle the scaling as required. So you have your personal computer, smartphone, tablet, and you can view this data. Now we have an application we did recently for one of the applications we've done is for a construction truck control system. So on this control system, we were communicating to the engine. We were displaying a lot of information on the HMI for the operator to control the gearbox and the motor and other devices. We had for example, in this application, we had a radio remote control that we're also connecting to. And we were logging this data on our ruggedized IoT gateway and transmitting it to cloud. And we were able to display data, generate alarms, emails, and any conditions and things like that. We're able to also set up geofences, for example. If when the truck left a certain area and returned to that certain area, would be notified, and certain alarms, faults, and things like that, we're able to track. And we have full graphing ability and data logging ability on the cloud. And the other cool thing, for example, with this gateway is if lost connection to the cloud, we're also able to buffer data on board. So we can store data, and then when we reestablish connection with the cloud, it sends the data to the cloud. So it's quite a nice solution. And this is an example application. So this is a project we've done in Australia. This is a low-pro haul truck. This has also been designed in mind to be able to be formed to have the cloud capability. So this is a manufacturing company, OEM in Queensland, and they're manufacturing these trucks. This is a really nice project where, as HYDAC here in Australia, we provided pretty much majority of the hydraulics, the cooling, all the sensors. We're communicating with the engine transmission and things like that. So it's quite a cool application. And we designed this in mind from a serviceability point of view. So we're able to, using the gateway, we're able to connect to the servicing, and we're also able to push data down to the machine. So we have a number of different ways we can service the machine, especially if they're in remote areas. There's a large amount of these manufactured around. So I hope you've enjoyed that. And yeah, please don't forget to register for our upcoming webinars. Please have a look at our webinars. You can find them through our website or through our YouTube channel. And please don't forget to rate and review, and any feedbacks or any suggestions on topics you want us to cover. Thank you very much.